DSCS Phase 2, the second stage of the Defense Satellite Communication System. This program represents the second phase in the procurement of satellites to support the defense communication system. These satellites provide many state-of-the-art improvements over the Phase 1 design, culminating in a substantial advance in operational communications throughout the Department of Defense. The program to develop this satellite system is managed by the United States Air Force Systems Command's Space and Missile Systems Organization, SAMSO. General Systems Engineering and Technical Direction is provided to SAMSO by the Aerospace Corporation. The design, development, and test of the satellites is being performed by the TRW Systems Group under a contract from SAMSO. Effort on this contract has been underway since March 1969. The Phase 2 satellites have incorporated narrow beam antennas mounted on a D-spin platform. These antennas provide the potential for focusing RF energy over a small portion of the Earth's surface, with an accompanying increase in channel capacity and privacy. Each narrow beam antenna can be driven independently in azimuth and elevation through gimbals, which are mounted on the D-spin platform. Maximum angular rate at which an antenna can be driven is 0.12 degrees per second. At the contractor's plant, each satellite was placed on a container pallet fixed to a transporter. A frame was attached to the forward end of the satellite to shield the antennas from damage and to support the protective bag. The protective bag was fitted about the satellite to provide additional environmental protection. The shipping container lid was lowered over the satellite and fastened to the pallet. The shipping container was designed to limit temperature change of the satellite and to maintain the internal relative humidity below 50%. On 4 October 1971, the first two DSCS Phase 2 satellites were loaded aboard a C-5A Galaxy at Los Angeles International Airport for the flight to the Air Force Eastern Test Range, Cape Kennedy, Florida. An instrumentation unit rode with the satellites to monitor accelerations, temperature, and humidity. The C-5A arrived the morning of 5 October at the skid strip of Cape Kennedy Air Force Station. The satellites and supporting equipment were unloaded and moved to the Satellite Assembly Building for a thorough checkout of all systems. The container lids were removed, and an overhead crane was used to transport the satellites to their test areas. Test equipment was hooked up to each satellite for an integrated systems test. The test was performed to ensure that no degradation in satellite system performance had resulted from the transportation environment. Data was compared with the factory data and system specifications to verify that the satellite was ready to begin its launch tasks. Other tests in the Satellite Assembly Building included a propulsion subsystem leak test and a solar array illumination test. After verification that all systems were performing satisfactorily, the satellites were stacked in launch configuration on the transporter. The protective bag was then installed. Early on the morning of October 18th, the DSCS Phase 2 Payload 1 began its last earthbound journey to Launch Complex 40 in its stacked bag, with an Air Force-supplied air conditioner unit connected. The satellites were pulled up to the mobile service tower. The hoist sling and nitrogen purge line attached along with ground straps and tag lines. The satellites were lifted up the length of the mobile service tower to the Universal Environmental Shelter. The stacked spacecraft were lowered onto the tram stage. The protective bag and forward frame were removed. The next 5 days were spent checking satellite system functions and launch vehicle satellite interfaces. After all remaining ordnance items were connected, the Titan 3C nose fairing was installed. The fairing is used to protect the two spacecraft from atmospheric heating during the early stages of the flight. To November 1971, launch day. TRW technicians completed final arming of the ordnance devices and placed the satellite on internal power. 30 minutes before the opening of the launch window, a Martin technician noticed that a thin metal band wrapped around one of the solid fuel boosters of the Titan 3C had slipped out of place. The mobile service tower was rolled back to the Titan and the metal band adjusted. The work platforms were then rapidly removed and the countdown resumed. At precisely 22:09 hours, the Titan 3C lifted off from the eastern test range, carrying the first two defense communication satellites for the Phase 2 system. The Titan 3C performed flawlessly throughout the powered flight and placed the satellites into the desired synchronous equatorial orbit.